We can map data points perfectly in digital space, but without a way to connect these isolated points, the data lacks meaning. Before the transformer architecture, language models relied heavily on recurrent neural networks, or RNNs. RNNs are systems designed to process text sequentially, one word at a time. This created a severe bottleneck. As a sentence grows longer, the information from earlier words gradually fades from the model's memory. Consider this test sentence. The cat didn't cross the road because it was too tired. Focus specifically on the word it. If a machine is reading sequentially and its memory of the beginning of the sentence is fading, it faces a problem. Does it refer to the cat or to the road? True machine comprehension cannot rely on a sequential timeline. To map context accurately, a system requires a mathematical mechanism that processes the entire sequence of words simultaneously. The transformer architecture solves this by shifting away from the sequential timeline. Instead, it locks all the words into a parallel structure, processing the entire sequence at the exact same time. This parallel processing is powered by a mechanism called self-attention. Self-attention calculates specific numerical weights that link individual tokens, the individual words or characters, to their relevant neighbors across the whole text. This chart shows a matrix grid mapping the words of our test sentence on both axes. Under self-attention, each token creates a new embedding, a dense mathematical representation of itself, by mixing in weighted information from all the other tokens. Look at the specific intersection point between the it row and the cat column. The attention score at this intersection dictates the mixture. The math gives a high weight to cat and a very low weight to road. So, when the model updates its definition of it absorbs a heavy dose of data directly from cat. This weighted mathematical mixing is the process by which an isolated word absorbs the necessary context of its surroundings. To calculate those specific attention weights, the mechanism generates 3 hidden vectors for every single token: a query, a key, and a value. You can think of the query as a specific question the token is asking its environment. The key is a label identifying what the token contains, and the value is the core info card it actually holds. During processing, the query vector for the word it scans the sentence, mathematically testing its fit against the key vectors of surrounding words, like road and cat. When the query for it finds a high-scoring match with the key for cat, that score dictates exactly how much of the cat value is absorbed to create the final representation. This specific calculation, query, key, and value, is the mechanical engine that translates human linguistic intuition into computable math. This diagram shows multiple overlapping attention matrix grids. This is multi-head attention. Modern transformers run multiple self-attention mechanisms in parallel to track different linguistic rules simultaneously. Each head focuses on a different layer of meaning. One might track basic grammar, while another maps long-distance dependencies. In models designed to generate text, we also apply a causal mask. This mask temporarily blinds tokens to any future text in the sequence, forcing the model to generate its answers strictly from left to right. These multi-head attention layers combine with feed-forward networks, systems that further process and refine the data, and are stacked repeatedly to form a complete transformer block. Passing data through this massive stack of attention layers is how large language models, or LLMs, AI systems trained on vast amounts of text to understand and generate human-like language, map out the complex, long-range relationships required to simulate true reading comprehension. Thank you for watching. At Knowledge Equity Partners, we provide practical, multilingual knowledge for your daily life. Please subscribe to our daily videos, like, and share. In Episode 5, we'll dissect a transformer block. See you then.